So for exercise 1 of this lab, we were asked to find the gain, which is V out over V in. And so first we're going to start with V minus here, and we're going to use a voltage divider to find what that is. Basically, we know that this voltage here equals this voltage here, and this voltage equals this resistor over this resistor plus this resistor times this voltage right here. And so by using that, we can find that since V plus is equal to V minus, that this is equal to V plus. And since we've defined V plus as our V input, we know that Vn equals R1 over R1 plus R2 V out. And we can divide this side by Vn and move this to the other side, and we get that our gain is R1 plus R2 over R1, or 1 plus R2 over R1. For exercise 2 of this lab, this is my circuit. I've got the potentiometer, which is going to feed a range of 0 to 5 volts into the op amp here. We've got a green wire, which is reading V minus. V plus is being fed in by that potentiometer, as I said. It's grounded. It's got a supply of 5 volts to power it, and we've got V out, which is being collected by pin A2, I believe. And this wire is basically making it a gain op amp here. And so this is my Arduino code, which is just reading those values and putting them into a string. And this is my processing code, which reads those values and plots them over time. And so this is what we have here, our processing. And my input voltage here is at about 2 volts. And if I increase that, everything will raise with it. And the only reason it looks like it's only blue here is because they're all equal to each other, as I define here in my derivation. So all it is the white and the green bubbles are behind that blue. You can kind of see if I move it fast enough that they're hidden behind there. So as it decreases, they all decrease, and the only reason it's stopping at 2 volts is just the design requirements of the op amp make it so that, as you can see right here, that it has an output range of 2 volts to 11.5 and an input range from 2 volts to 11.5. For exercise 3, this is what my inverting amplifier looks like. So I've got same thing, this white wire that's providing a voltage of 0 to 5 volts connected to a resistor connecting to that V minus, and that's being collected into this green wire into port A1. A2 is collecting V out again. We've got a voltage source, a ground. This orange wire is creating a 2.5 volt ground for V plus, which is being read into pin A3. And we should have a gain of about 10 here. And so when we look at the processing screen, I now have, if I raise my VS, of course V out has that limit of being a minimum of 2 volts, so it stops there. But if I go negative, you can see once we pass 0 volts that V out raises a lot faster than V out decreases, and we'll find out that that is at a rate of about 10. Yellow is going to remain constant because we're keeping it at that 2.5 volt ground, and then green is moving with that V in, because as you can see from this diagram that they're just separated by a resistor, so they're going to be proportional. For exercise 4 of this lab, I've got a similar configuration as exercise 3, except I've switched this resistor with one that's 4.7 kilo ohms, I believe, and instead of a resistor here, we've got a 10 microfarad capacitor. And I've derived the gain for this circuit here. It's similar to exercise 3, but since we're using a capacitor here, we have to use that complex impedance. And I get that it's inverting, and we're going to get a gain of about like 20 over whatever j omega is. And so when we look at our processing here, we can see as we increase V in, our V out will go down, but since we've got a minimum of 2 there, we can put it down and see once we pass 0, our V out will go up by a lot. And so that's going in the opposite direction as V in. V plus is going to stay that constant 2.5 again, and V minus is going to follow the same trend as our V in.